Assalamualaikum warahmatullahi wabarakatuh. Today we continue on next topic, which is subtractor circuit. Okay. So previously we have learned how to use a 4-bit parallel adder to form the additions. Okay. So the 4-bit parallel adder actually we can modify to form a subtractor circuit. So the process of subtraction, okay, for example, S equal to A minus B, okay, by using two complement. So it's performed as this process. Okay. So you will get A minus B is actually equal to A plus with B bar plus 1. So how you get this process? So if you remember in the two complement arithmetic that you have learned in previous lecture, so if you have subtraction, so the process is actually A plus with negative B, right? So how you get the value of negative B or negative? Yeah, so the process of negative into complement A, you can get the value by complement each bit, okay, and then you add 1, okay, to the complement value. Okay, so you will get, okay, negative B is actually comes from B bar, which is you complement B and then you add 1. Okay, so you will get negative B. So that's why based on this, you can be summarized as A plus with B bar plus 1. So this is how you get the value of A plus B bar plus 1. So it comes from this process, okay, A plus negative B. So how you get negative B? By you complement B and then you add 1. So the two complement for B is actually you obtain by complementing each bit and then you add 1 to the least significant bit. Okay, so we will perform the process of subtraction, okay, by using this format, okay, or this process. Okay, you have 4 bit for A, 4 bit for value B, okay, and then each bit for value B you need to complement, okay, and then you add 1 to the least significant bit. Okay, so you will get sum, and actually here you have C in. Yeah. Okay, so each column here is actually you have C in that you need to add together with the value of A and also the complement of B. So you will get your sum results. So this is a process of addition in 4 bits, okay, by using subtractor circuit. Right, so this is the 4-bit subtractor circuit. Yeah, so if you remember the 4-bit parallel adder, so it's quite similar with the subtractor circuit, okay, except if you refer to this circuit, there is one gate that you need to connect with your B, okay, which is the NOT gate. Okay, why we need to connect each B, okay, with NOT gate? Yeah, so this one you need to refer to this process of subtraction. Yeah, so if you refer to this process of subtraction, okay, especially for B value, each B must be complemented. So you need to think what is the logic gate, okay, that can perform the process of complement. Okay, so the logic gate that can perform the process of complement is gate NOT. Okay, so that's why B must be connected to NOT gate, yeah, to represent the B bar. Okay, and then for this 4-bit subtractor circuit, we need to use all 4 full adder. Okay, why? Okay, because each column, okay, you must add by 3 bit or 3 value. Okay, so next column you have another value which is C in. Okay, so if you refer, we have 4 columns here. Okay, 1, 2, 3, and 4. Okay, based on each column, all 4 columns must be added by 3 value. Yeah, so that's why we need to use full adder, because full adder the input we have 3, okay, which is C in, A, B. Yeah, so this is the first column, okay, represented by first full adder, okay, and then this is the second column for S2, yeah, A2 and also B2, and then this is the third column, and then this is the fourth column. So each column is actually represented by one full adder. Okay, and then each column, when you add between A, B bar and 1, you have S1 and also the C out. So C out must be connected to the next column, which is it will becomes the C in. Okay, so this CO will be connected to the next full adder and becomes the value of C in. So you'll carry the same value from the C out. Same goes with the next full adder and the last full adder. Yeah. So this is the 4-bit subtractor circuit. So you must remember the differences between full adder, 4-bit parallel adder, and also 4-bit subtractor circuit. So the difference is actually you need to connect your B, okay, with NOT gate, okay, based on this process. And then this diagram is actually shows you the 4-bit subtractor circuit, okay, by using 7483 adder, which is a full adder, yeah, in circuit maker. So this is actually the circuit that drawn by the circuit maker. Okay, so you will learn in your lab session, okay, how we can perform the subtraction and also of course the addition, okay, by using the devices, okay, in circuit maker. Now we look at the example, okay, how we can perform the subtraction, okay, by using the subtractor circuit, okay, or the process of subtraction. Okay, right. So these two examples is actually based on this format. Okay, based on this format. Okay, so you have 4-bit for A, okay, 4-bit for value B, okay, and of course you need to add 1, okay, to get the value of your sum. So example 1, okay, 7 minus 1, the expected result will be positive 6. So based on this example, okay, you need to represent each value by 4 bits. Okay, why we need to use 4 bit? So same with the previous lecture, you need to determine the range, okay, how many bits that you can use to perform the subtraction. Okay, so based on these 3 values, so 7 is actually the largest value, the biggest number. So the range for 7 is 4 bit, and that's why you need to convert or represent, okay, each decimal by using 4 bits. So A, yeah, by using 4 bits, so you will get 0, 1, 1, 1, 1, 1. Okay, B in 4 bits is 0, 0, 0, 0, 1, and then you plus with 1. Okay. So how to perform the subtraction? So this is actually follow this format, okay, for subtraction. Yeah, so before you get the result, which is positive 6, so this is your result, positive 6. So you must complement each bit for B. Okay, B. Okay, so B you must complement each bit. Okay, and then lastly you will add 1. Yeah, you add 1. Okay, for example, 1 plus 0 plus 1, you will get 0, 1 as your C in. Okay, 1 plus 1 plus 1 is 1, 1. Okay, so 1 plus 1 plus 1 is 1, 1. Okay, 1 plus 0 plus 1 is 0, 1. So actually you have extra 0 or carry out. So this carry out value must be deleted or omitted. So your last answer just 0, 1, 1, 0 equal to 6. Okay, so this is actually the value of 7, and then this is actually the value of negative, okay, negative 1. Okay, this is the value of negative 1. Yeah, so negative 1. Yeah. So this one lah. Yeah, based on these two, is actually value the negative 1. Okay, so same goes with the example 2. Okay, 7 minus 0. So in this example also you need to convert it into 4 bits. Okay, and then the value of B you must complement each bit. Okay, so you will get this value, and then you add bit by bit. So you will get your answer, which is equal to 7. Okay, so 7 minus 0, you will get 7. Okay. So the process of subtraction by using subtractor circuit is actually you need to use this format. Okay, you need to use this format. Slightly different with the method that you learned in the previous lecture, into complement. And so if you remember, into complement, you need to find the value of negative. Okay, and then when you get the value of negative, so you will add with the value of positive value. Okay, for example, for this one, 7 minus 1 is actually 7 plus with negative 1, right? So into complement previously, you need to find the value of negative 1, okay, and then you will add with the value of 7. Okay, but now for this process, for subtraction in subtractor circuit, so the whole step is actually we show in one full method. Okay, in one full method, or in one full process or step. Yeah, so you doesn't have to show differently how you get your negative, okay, and then you add. So you just add the whole value in one step. And then okay, this is just in circuit maker also. If you want to perform the 8-bit, so you need to connect between two full adder. Yeah. Right, so another example, this one is actually the process of subtraction, but now we represent the value by using 8 bits. Okay, quite similar with previous example, just for this example you need to show in 8 bits, that's it. Okay, you need to show the 8 bits, but the process still use the same process. Okay, you need to complement each bit for B. Okay, so this is actually value B, so you complement, okay, so you will get this value, okay, for B, and then you need to add column by column. Okay, this is another example, example 2. Okay, so for this example, so you need to represent each decimal value by using 8 bits. Yeah, so 7, okay, subtract 1, okay, expected result will be 6. So each decimal value you must convert it into 8 bit. Yeah, so the step is actually quite similar with the previous. Yeah, just the process is using 8 bit. Yeah, so you have A in 8 bits, and then B also in 8 bits. Okay, and then you need to add 1. Yeah? And the whole process of subtraction is actually the second step. Okay, the important part is second step, which is B. Okay, you need to complement B. Okay, so after you complement B, you will get this value. Yeah, so this is a positive B. Yeah, because the first step in finding the negative value is you need to find positive. Okay, so this is a representation of positive B, which is positive 1. And after you complement B, you will get this value 1, 1, 1, 1, 1, 1, 1, 1, 1, 0. And the last step, okay, you need to add 1, okay, which is the C in value. Yeah? So you need to add column by column, and lastly you will get the results, okay, which is equal to positive 6. Okay? So this is actually how you can perform the subtraction, okay, by using the subtractor circuit. Yeah? A bit different with the previous process, into complement process. Yeah? So in this process, you just show the whole operation in this one method. Yeah? In this one method. Yeah? So the most important part for the subtraction using the subtractor circuit is actually the second part, which is the value of B. Okay, so you need to complement. Okay, you need to complement each bit B, so you will get this value. And after that, okay, you need to continue the process by adding the value of C in, okay, to the least significant bits. Okay, only to the least significant bits. And then the next column, okay, you just add, okay, by this both value, and of course the including the C in value. So there are also the value of C in, okay, on top of this value. Okay? So this is the examples, okay, how we can perform the subtraction, okay, using the subtractor circuit.